plus, and you would write its name in here. And I'm not going to do it, but you could write, I always write Berkovich or whatever type of tip it is, and then the date, so you know. And again, the same tip can have multiple different calibrations that are all valid. You want to keep them all, because what is good now might not be good 6 months from now when you've indented a lot and maybe worn down the tip a little bit, right? So for instance, right now there's this Berkovich 915 2015 tip in there, and you can choose different ones if you want. All these different ones here, flat punch, whatever. But so if you have a brand new tip, which we actually do have right now, I would make a new tip by going to machine settings and this plus button, right, and it would come up, and it would just have some default values in here, like 24.5, and then everything else is 0. That's like ideally what it should be, but that's not exact. So then to calibrate it, I would go to tip and settings, advanced tip calibration, and then hit calibrate. It's fitting on the data that we have up right now, and then I would hit accept, and it would change the values of this tip that I had selected or that I had just created. It would change them to whatever it found here.
The tip, you mean the indented tip?
Yes.
Okay.
Yeah, and you can tell what tip you have selected or what it's going to do by looking right here. It says tip. And it also should show it here. So that's the calibration procedure, and again, it's outlined probably better than what I can show you right here. And another trick is that I can actually, by changing the tip here, I can actually change the calibration I apply to a certain data. So I can take this data with an old calibration, I can recalibrate the tip on the fused silica, and then I can apply that new calibration to this data and see what it does. It's not always useful, but just so you know, you can do that. And then, so you do that by changing the tip here. Say I want this one instead, and I would hit accept or save and close. And then you could go up to sample data and recalculate. It would recalculate everything, and then the data would look slightly different because it had a slightly different calibration. Because the assumption that would be changing would be a slightly different tip shape, or a slightly different cross-sectional area as a function of contact depth is really the thing. So that's the calibration. Do you have any questions?